Hey everyone, this is Unit 3 Notes number 10, Converting Degrees to Radians. So go ahead and write down your FLT and press play whenever you're ready, okay? Okay, so, in the last few lessons, before we kind of continue, just to recap, we were able to learn how to find missing sides of a triangle, how to find missing angles. So we used the Pythagorean theorem. If we had two sides, we need to find the third missing side. We also introduced special right triangles with the 45, 45, 90 and the 30, 60, 90. And then we figured, well, if the angles aren't special, what do we do? And that's where the trigonometry comes in, right? That's where we learn about sine, cosine, and tangent, right? SOHCAHTOA, to remembering the ratios. And then you guys learned that there were actually three other trig functions, the reciprocal functions, cosecant, secant, and cotangent, right? And then you learn how to find a variety of ratios when you're given certain things, right? And I think the last thing that I left you guys off with was learning how to figure out what the signs are, S-I-G-N, what the signs are, whether it's positive or negative, depending on what quadrant you're in. Okay, now that's going to make a little bit more sense logically when we get into the graphs of it. But until then, just remember, all students take calculus, ASTC, to remembering what comes out positive and what doesn't. Okay, so today we're kind of taking a step to the side because there are things that you guys are going to run into, specifically angles. So you guys know that when you have a trig function, whether it's sine or cosecant or cotangent, there's always an angle that goes after it. Okay? Now, in general, if we don't know what the angle is, we put a theta there for the most part. Sometimes they'll use a letter, sometimes they'll use a different Greek letter, okay? But it's a symbol that represents the angle. Now, what you guys have to understand is kind of like how when you measure how tall you are, if you were, let's say in the US, if someone were to measure how tall you are, I guess I should use weight. Weight is a better example. So, we use pounds, right? LBS. So if you weighed 120 pounds, right? In the other parts of the world, they won't use pounds. They'll use kilograms instead. So it's just a matter of a different unit. So same thing with angles, okay? With angles, you're either dealing with either of two types of units. So what you guys are used to is degrees. And then there's something else that's called a radian. And I'll show you guys why that's so important. It's not just extra work that you're trying to deal with here, but we're used to degrees, and then we're going to learn what a radian is and how do we convert to a radian there, okay? Okay, so for instance, degrees looks a little bit like that symbol right there, degrees, right? It's to measure how wide that angle is. So with a radian, first, what is a radian? Okay, so we'll go with that. Now remember on your calculator, whether you're using the phone calculator or not, okay, there has to be some type of mode. So for instance, right now, currently on mine, it's in radian mode. Now what that is, we'll talk about in a second. Okay. Now, if it doesn't say anything there, it's implied that it's in degree mode. Okay, so we talked a little bit about this in the previous lessons. If you're not using the iPhone calculator, if you're using a scientific calculator, you might look for a button called mode. Okay, and on your screen, it should either say DEG or RAD or maybe even GRAD. But just make sure that you know that you're in the right mode here, okay? So for the most part, we've been dealing with degree mode. Then we're going to introduce to you guys, well, what the heck is this rad or this radian mode here, okay? Okay, so first, we got to understand what a radian is. So I want you to pause here and really think about this. But what comes to mind when you see the word radian? Press play when you're ready. Okay, so a radian sounds a lot like radius. Okay, a radius. They're very similar, and they're actually closely related. So just to give you an idea of what a radian is, here is a radius in blue. I'll highlight it right. I'll highlight it right here. This is your radius right here. That's a radius. This is also a radius right over here in blue, okay? In fact, there's an infinite amount of radius, or radii, plural. Now, what you want to remember is a radius is where you go from the center of the circle, so the center of the circle, out to any point on the circle, okay? So that is called a radius. So a radian is basically when you take, let me erase that real quick. When you take the length of this radius and you take it and you want to lie it on the arc or the curve, okay? So I'm going to illustrate this for you guys real quick. Take a look at this here. So notice how that blue line, that blue radius is the same length as the red line. That red line kind of curves and it kind of hugs the circle here. When the length of the curve is exactly the same measure as your radius, we call that a radian. That's 1 radian there, okay? So, for instance, so right now I'm kind of moving it around. So right about here is 1 radian. And notice if I go to 2 radians, that's what it looks like because that's the length of 2 radius or radii in plural. That's equivalent to the length of 2 blue radius or radii. Okay, so what's my point, right? Well, notice how when I go to 3 radians, it's almost completing half of a circle. Okay, it's a little bit shy of a half of a circle, a semicircle there, okay? So my question is, and you guys might see it already, is how do we get a half circle perfectly, right? This is where pi comes from, okay? You guys know that pi is roughly 3.14159, yada, 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 right? So approximately at 3.14, that is exactly a semicircle. Okay, so how much does it take to complete a whole circle? Think about that before you answer. So if you take a look, if I wanted a full circle, that's about 2 pi or roughly 6.28, right? So a radian is basically the length of a radius that's on the arc or the curve. Arc is just a fancy term for the curve, okay, or the circle. So if we wanted to wrap the entire circle, it would require 6.28 radians, or roughly 2 pi. All right? So here's what we know. Okay? We know that, let me draw a picture here. Hopefully I don't butcher this. There we go. Okay. So let's say we had a center. Okay. And we have that blue radius, right? Okay. Whatever that length is, even if you made a giant circle, the radian is always in reference to the length of the radius. Okay. No matter how large Like even in this picture, even if I dilate it, if I made the circle bigger, the radian is still in reference to the radius of that circle. So if the circle is really small, then the radian has that same length in reference to the radius, okay? If the circle is really big, the radian is also the same length as the radius, okay? So it doesn't matter what the size of the circle is, all right? So let's write this down. A radian is the arc length equal to the length of a radius. Okay? Remember, arc just means the curve, okay? If you were to kind of walk on the curve, so the radian is the arc length equal to the length of a radius. So I want you guys to remember, this is the big takeaway here. Let me see if I can straighten this out. Oh, that's terrible. Let's try that again. If I were to go all the way across, okay? Think about that there, okay? From here to here, how many radians did it take? Okay? How many radians did it take to complete half a circle? So I'll bring you guys back to this just so we can see. How many radians did it take to complete just half a circle? So just half. Okay? Notice how it takes about 3.14 radians, also known as pi. It takes about 1 pi radian to complete half a circle. What the heck is my point, right? So let's write this down. 1 pi radian is the same thing as half a circle. Now, what is the angle here when you go half a circle? Okay? You guys know that when you spin in a full circle, how many degrees is that, right? Press play when you're ready. If you spin in a full circle, that is 360 degrees. So what if you spin in just half a circle, which is what we have in this highlighted picture here? That's 180 degrees, okay? So here's a conversion that we just discovered, okay? We know that 1 pi radian is the same thing as traveling 180 degrees. Make sure that you guys box this, highlight it, do whatever you need to do. Super important. So that's the logic behind it, okay? That if you were to open your angle up all the way to 180 degrees, it makes a semicircle, which requires that you travel about pi radians to get that semicircle, okay? So we know that 1 pi radian is the same thing as 180 degrees. So we're going to use that to convert, okay? So here we go. Think back to chemistry. Some of you may be taking it currently. Some of you, it's been a while, right? But let me review. Let's just think of something simple here. Let's say that you have a 60-inch TV, okay? And you want to know how many feet that is, all right? So you ask yourself, well, what do I know about inches and feet? Okay? Pause this video and really think about that. What do you know about inches and feet? Press play when you're ready. I know that for every 1 foot, there are 12 inches. It's a ruler, okay? Okay, and I know that for every 12 inches, there's 1 foot, or feet, if we want to call it that. So here's what you do. back in chemistry, you guys learned something called dimensional analysis. And you might not have remembered that term. It's okay. But here's what you do. Some people call it a T-chart. But basically what you're doing is you're separating the numerator and the denominator. Okay? So you notice right here that this is inches. So if you want to get rid of it, you're going to put it down here. So I'm going to put inches down here as well. Whatever you want to cancel out, you put there. What you want to put on top is what you want to convert it to. So I want to convert it to feet. So I put feet at the top. Okay? So now, just looking at this section alone, okay, what do you guys know about feet and inches? So there are two options here. Is it, 12 feet makes 1 inch? Or is it 1 foot makes 12 inches? Think about where things would go and where it would make sense, okay? Press play when you're ready. It doesn't make sense to say that 12 feet is 1 inch because that doesn't make any sense. So we know that 12 inches makes 1 foot, all right? Mathematically, this causes the units, inches, to cancel out because you have one at the top and one at the bottom. You're like cross-reducing in a sense, okay? So all you have left is feet, okay? So if you multiply the top here, and I'll highlight it so you can see, 60 times 1 feet is 60 feet, or FT for short. Okay, let me go ahead and move this real quick. Okay, and down below is just 12. The inches went away, so I'm not going to write inches, okay? So I'm left with feet, which is what I want. 60 divided by 12. You can use a calculator if you like. 60 divided by 12 is 5 feet. So what does this really mean, right? This is saying that 60-inch is the same thing as 5 feet. So your 60-inch TV is equivalent to 5 feet. All right? So it's written differently, but it's equal. I want you guys to remember that. It's written differently, but it's equal. Okay? So it's the same idea here. You're going to be given angles in degrees. We're going to try to find out what it is in radians so that it's equivalent, all right? So remember that 1 pi radian is the same thing as 180 degrees. Okay, here's example 1. We'll write the directions out in its entirety here. Convert your angle to degrees. Sorry, not to degrees, to radians. Hold on. In simplest form. Okay? So first off, what do we want to do, right? We want to convert our angle to radians. And we want to make sure that our answer is in simplest form, meaning that everything is reduced. Okay? Most of the time, you guys are going to be dealing with fractions. All right? Okay, so here we go. So I'm going to do a bunch with you guys. Let's say I gave you 30 degrees. That little circle at the top, it kind of looks like an exponent. That's degrees, okay? So here's what you do. Some of you, I'll do it both ways, and I'll let you guys decide which way you're more comfortable with. So in chemistry, there's something called that T-chart, right? It's really to separate your numerator and your denominator. So your eyes are going to go here first. Let me just show you. You're going to take a look at the units. That's degrees. So right away, you want that down here. So I'm going to go ahead and put degrees down here. And we want to convert it to radians. What you want to convert it to, you put on the top. Okay? What you want to get rid of, you put at the bottom. So think about this section alone, just like we did before. What do you guys know about radians and degrees? So right here, we know that 1 pi radian is the same thing as 180 degrees, okay? I wouldn't put 180 at the top because 180 radians is not the same thing as pi degrees, right? Okay, so here's what happens, okay? So because we put the degrees diagonal to each other, or one on the top and one on the bottom, that allows that unit to reduce out. And all we're left with is everything that's not crossed out. So we'll work from left to right here. Here we go. Let me get rid of the pink highlight so you guys aren't confused. We have 30 times 1 pi radians. So that comes out to 30 pi radians. Okay? Down below, the only thing I have here is 180. The degrees is no longer there because it canceled out, so I just have 180. All right? So here's the thing. That 30 and that 180 can actually reduce. Can you guys think of a number that we could divide both of these by so that we can reduce it? Okay? Their greatest common factor is actually 30. Now, if you guys said 10 or 5 or 6 or any other number, that's fine, but that's just going to require you to reduce some more, and I'll show you that, okay? So if I were to divide the numerator and denominator by, let's say, 30. And feel free to use a calculator here, okay? I don't mind. You would end up getting 1 pi over 6 radians. Okay? Now, let's say you didn't know that it was 30, right? So let me just show you here real quick. Let's say that you thought that you could divide both by 10. Okay? If you divide both by 10, that's fine. You're going to end up getting 3 pi over 18. But notice how you still have an opportunity to keep reducing. Remember that we want the simplest form, meaning that it has to be completely reduced. Here, I could still divide by another 3 and then get pi over 6. So it doesn't matter how you reduce it as long as you reduce it all the way. Okay? So here's the last thing that I'll talk about before we try a few, okay? When your answer has a pi in it, there's no need to write radians because it's kind of redundant. Because if it's already a pi, you know that it's already in radians. So sometimes in your book or wherever you would find out this math stuff, maybe through YouTube or just some online resource, they might just write pi over 6. So there's that radian there. It's just like a little bit invisible. Okay, but there's really no need to write it. It's really up to you. So on Delta Math, pi over 6 is good enough. You don't have to write pi over 6 radians. In fact, I don't think you can type radians there, okay? So what does this mean? Here's the big takeaway, you guys. We started out with 30 degrees, okay? We ended up with pi over 6. How are these two related, okay? Pause if you need to. 30 degrees and pi over 6 look very different, but they're actually equivalent. Okay? It's like, again, that example where in the US we measure ourselves in pounds, but maybe somewhere in Europe or Asia they measure you in kilograms, right? It's written differently, but it's still equivalent. All right? So same thing here. In trigonometry, in this unit, when you're dealing with all of your sine, cosines, and tangents, you have to know the difference between a degree and a radian, Okay, and sometimes it causes you to convert. All right, so let's try a few. Here's part B. 45 degrees. Okay, now here's the other method, I should say. Not really a method. The T chart was kind of like chemistry's way of getting you guys to have things organized, right? And you can totally do that. Mathematically, what's happening is this. You're pretty much multiplying by another fraction. Okay? So this is the other way of doing it. Same idea though. You look at what you're starting with and you want to put it down here to get rid of it. Okay, so I'm going to have degrees down here and I want radians up here. Sometimes they'll say rad for short. That's fine too. I know that 1 pi radian is equivalent to 180 degrees. So it's the same thing without the entire T chart, right? Okay. Degrees cancels out because they're diagonal to each other. There's one at the top and one at the bottom, so it could reduce. And you're just left with 45 pi radians over 180. Not degrees, just 180 because the degrees canceled out. You now want to check to see if you can reduce that right there. Okay. Pause here and try to reduce that as much as possible. Okay. So some of you may initially divide by 5. Some of you initially may divide by 9. The greatest common factor here is actually 45, but I'll do it the way that I think. For those that may not be good with fractions, this is probably what you guys would do, and that's okay. I would divide by 5, okay? Then I end up getting 9 pi radians over 180 divided by 5. Oh gosh, what is that? That is 36, okay? But then I noticed that I could still reduce the 9 and the 36. I know that I can divide by 9 for both. And that'll give me pi over 4 radians. But all I really need is the pi over 4. Okay? If you got that, good. If not, let's try another or text me. Okay? If you're not really sure where your mistake is, let me know. So if you guys take a look at this in its entirety, the toughest obstacle here is reducing your fraction. The T chart is something very minor that I think everyone can pick up. Okay? All right, let's try a few. So whether you wanted to use a T chart or if you just want to write it mathematically, I'm going to leave that up to you here. Okay? Either way gets you the right answer. It doesn't matter how. So I want you to try this one here. And then press play when you're ready. When you're all done, or if you need help, press play. Okay, so here, 60 degrees. Since I'm starting with degrees, I know I want degrees at the bottom, right, to cancel out. And I want to convert this to radians. I know that 1 pi radian is equivalent to 180 degrees. So in a sense, I'm kind of multiplying by a giant 1. Okay, so that's why I'm not changing the value. Okay, degrees cancels out. I'm going to be left with 60 pi radians, or rad, over 180. RAD is just an abbreviation of radians, okay? Kind of like on your calculator, how it says RAD. So now you guys have an idea of where it comes from, okay? All right, 60 and 180, we can definitely reduce that. The greatest common factor here is 60, but don't worry if you did use it. As long as you keep reducing, you should still get the same answer. Okay, this ends up being pi over 3. Now there's that 1 in the front, the 1 pi, but really you don't need that 1 because it's kind of like invisible there, right? So I'll just leave that empty. All right, that's it. Let's try a couple more. Here's part D. Let's do 120 degrees. Okay. Try that on your own and press play when you're ready. Okay. So here, again, we start with degrees. So we want to end up with degrees. And we want to get rid of degrees, and we want to end up with radians. Okay. I know that 1 pi radian is equivalent to 180 degrees. Okay. That cancels out there, the degrees. You're left with 120 pi radians over just 180. Okay. Take your time here with the reducing. I believe the greatest common factor here is 60, but again, don't worry if you didn't come up with 60, as long as you continually reduce when it's possible. Okay? So here, 120 divided by 60 is just 2 pi radians, and 180 divided by 60 is 3. Okay? So this is really 2 pi over 3. And it makes sense because, think about this here. Here's another way of thinking about it. 120 degrees is twice the amount of 60 degrees. So 60 degrees is pi over 3, then 120 has to be twice the amount. Okay? So something to think about there, okay? All right. Here's we'll do 2 more, okay? Let's do 300 degrees. Okay. Press play when you're ready. Okay. So if we start with degrees, we want to have degrees at the bottom so that we can cancel it out. And then we want to end up with radians because that was the task, right? We know that 1 pi radian is the same thing as 180 degrees, not the other way around. And then that would cause the degrees to cancel out here because they're diagonal to each other, or in the numerator and the denominator. So we're left with 300. Ooh, I'm losing my voice. 300 pi radians over 180. Okay? So notice how these numbers are getting larger, right? So let's say you didn't know what the GCF was, right? I know that they both end in zeros, so I could easily divide these by 10. Okay, so 300 divided by 10 is just 30 pi radians over 18. So we're allowed to make the number a little bit smaller, so it's more manageable. Okay, so now we have 30 and 18. What could I divide 30 and 18 by? Well, let's try 6. Okay, 30 divided by 6 is 5. 18 divided by 6 is 3. Okay, can I keep reducing? Okay, 5 and 3, there are no common factors there, so I know that I've reduced it all the way. So you could put radians there if you want, but most people do not. All right, so 5 pi over 3 is the same thing as 300 degrees. Okay, here's one more. Last one. Let's say we had something crazy like 405 degrees, okay? Go ahead and try that there. Okay, so same thing. Actually, let me do the T-chart for those of you that like the T-chart. Okay, so we know that we start with degrees, so we want the degrees down here. We want to convert it to radians, and I know that 1 pi radian is the same thing as 180 degrees. Okay, that causes the degrees to reduce out. And we're left with 405 pi over 180 radians. Okay, so these numbers are pretty large, so what I'm going to do is just work with what I know. I know that both of these will go into 5 for sure. Okay, so 405 divided by 5 is, oh gosh, what is that? 81 pi. And 180 divided by 5, that's going to be 30, I want to say 6. 3, 15, 30, 36. Yeah, that looks about right. Okay. Can I keep reducing? 81, 36. I know that, I could divide these by 9. 9 definitely goes into both of them. 81 divided by 9 is just 9 pi. 36 divided by 9 is really just 4. Okay? So, I know 4 can't go into 9, so I think I'm done here. 9 pi over 4 is the same thing as 405 degrees. Okay? So here's what I'm going to leave you guys. Okay? Here's some trivia for you. Not really trivia, but here's some questions for you, okay? Recall our quadrants. And I'll draw it up here real quick. Recall our quadrants, okay? There are 4 quadrants. How do we label it? Press play when you're ready. Remember, we start counterclockwise from the positive x-axis. So we go this way. Okay? So we have 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Look back in your notes. Here's what I'm going to ask you guys, okay? We have A, B, C, D, E, and F. I want you to go ahead and label what quadrant that angle is in. So I'll give you the first one just to give you an idea. I know that 30 degrees is somewhere in between 0 degrees and 90 degrees. So I know it's somewhere in quadrant 1. Okay, label the rest. Okay, 45 degrees is still somewhere in between 0 and 90, so I know it's going to be quadrant 1. So that means pi over 6 is also in quadrant 1, and pi over 4 is also in quadrant 1. Same idea, right? Because they're the same thing. 60 degrees is still somewhere in between 0 and 90. So 60 degrees and pi over 3, since they're the same thing, they're still stuck in quadrant 1. Okay? 120 degrees is somewhere between 90 and 180, so I know I'm in quadrant 2. So 2 pi over 3 must be in quadrant 2 as well. All right? 300 degrees is somewhere in between 270 and 360. So I know I'm in quadrant 4, IV there. So that's quadrant 4. So here's my last question to you guys. Where the heck is 405? Right? We're so used to just going from 0 to 360. So where is 405? Okay? So if your guess was quadrant 1, you're absolutely correct, okay? If you guys have ever watched any sports of some sort or just spinning in general, okay? Sometimes think about a snowboarder or a skateboarder, right? If you spin once, that's 360 degrees, right? In a full circle. Well, what if you spin twice? That's 720. What if you spin 3 times? Right? That's 1080. Right? So sometimes you go beyond the 360. So 405 degrees is basically 360 plus a little bit more. 360 plus 45 gives you 405. So 360 will get you this. So you're currently right here. Actually, let me draw that one more time. 360 is this full circle. Whoa, that was pretty cool. But then you go a little bit more, 45 degrees. So notice how you're still ending up in quadrant 1. Okay, these are called coterminal angles, which we'll talk about in the next few lessons. Okay, so the big takeaway, the quadrants was not the big takeaway. Okay, that's just to revisit some things that we've seen before. Okay, the big takeaway is know how to convert, know how to reduce. Okay, take your time on the reducing. It's okay if you don't always find the GCF. You could just keep reducing by small numbers until you get to what you need. All right. That's it. Practice. Let me know how you guys do, and text me if you guys need support.